This is Lesson 9, Factoring Polynomials. In this lesson we are going to learn how to factor general polynomials as well as some specific types of polynomials. Now whenever you are factoring polynomials, regardless of what type of polynomial you have, you need to start off by the very first thing is to look to see if you have any common factors in all of the terms. So if we start by looking at this very simple polynomial, AB plus AC, it's got two terms, AB and AC, but notice you do have a common factor. Both of these terms have A within them, so therefore you can factor the A out. And if you do that, you get A parentheses B plus C. Now, whenever you're factoring, another thing to note is the fact that you can always go backwards and check your results. For example, if I were to distribute the A to the B plus C, I would get back to AB plus AC. So you always can check your factoring to see whether or not it's correct. So let's look at another example. 18x to the third plus 27x squared. Okay, so we have two terms here. Do we have anything common? Well, both of the terms have x in them. And if you look closer, actually both of the terms have x squared in them, since x to the third is simply x squared times x. Then if we look at the 18 and the 27, we can see that both of these have a factor of 9. So therefore, we should be able to factor a 9x squared out of this expression. Now by doing this, we should end up with 9x squared parentheses 2x plus 3. Common factor, 9x squared, factored it out, this is what we got. Again, if we distribute the 9x squared to the 2x plus 3, we'll get back to the original expression. So therefore, our factoring is correct. So let's look at another expression. X squared, parentheses x plus 3, plus 5, parentheses x plus 3. Basically, we've only got two terms here. Now, is there anything common? Is there a common factor? Well, if you look closely, you can see that we have x plus 3 here, x plus 3 there. So we have a common factor, x plus 3, which we should be able to factor out. And this results in x plus 3 times x squared plus 5. So remember, very first thing you do whenever you're factoring a polynomial, look to see if you've got common factors. Now let's look at a type of factoring for a very specific type of polynomial, and this is one which has 4 terms. And this is called factoring by grouping. So let's take a look at an example to see what we mean by factoring by grouping. So for an example, let's look at x to the third plus 4x squared plus 3x plus 12. Again, first look to see if you've got a common factor in all 4 terms. We don't. 3 of the terms have x, the 4th term doesn't. The coefficients don't have a common factor, so therefore we do not have a common factor in all 4 terms. However, let's take and look at the first group of terms, x to the third plus 4x squared. We can see that these two terms have a common factor x squared, and if you look at the second two terms, they have a common factor of 3. So let's see what happens when we factor out these common factors. So we now have x squared times x plus 4 plus 3 times x plus 4. But notice, we again have common factors here of x plus 4. So let's factor out the x plus 4 and see what we get. So our final result becomes x plus 4 times x squared plus 3. Now, let's look at some other methods for factoring very specific types of polynomials. What if I have two terms separated by a minus sign? We need to look to see if by chance we have the difference of two squares, because then there's very specific rules for how to factor the difference of two squares. So let's just say hypothetically that our example is a squared minus b squared. We've got two terms separated by a minus sign. Now if we look at this, we can see that the a squared and the b squared, the two terms, are perfect squares. So what is the rule for factoring the difference of two squares? The rule states simply that this is equal to a plus b times a minus b. So whenever you have the difference of two squares, it's equal to a squared minus b squared. It's equal to a plus b times a minus b. So let's look at this example. X squared minus 4. Two terms separated by minus sign, and both x squared and 4 are perfect squares. And the result here is simply x plus 2 times x minus 2. So let's look at another example. 81x squared minus 49. This is two terms separated by a minus sign, but are they both perfect squares? Well, 81 certainly is, x squared certainly is, and so is 49. This is simply equal to 9x plus 7 times 9x minus 7. So now, what about the case where you have two terms, but instead of them being perfect squares, they're perfect cubes? So what if you get a case of a to the third plus b to the third? What is this equal to in terms of factoring it? This is simply equal to a plus b times a squared minus ab plus b squared. Now there's no easy way around this, that you pretty much have to memorize the sum of cubes, what they are equal to in terms of factoring. Similarly, how would you handle a to the third minus b to the third? Two terms, but now we're talking about the difference of cubes. This is simply equal to a minus b times a squared plus ab plus b squared. Now you can do some things with the signs to help you memorize this. When it's difference, it's a minus b, and the middle term of the second is plus. If it's a squared plus b squared, then it's a plus b, and the middle term is minus. However you want to do it, pretty much is you have to memorize the sum or difference of cubes. So let's sum up. What should be our strategy for factoring a polynomial? So what steps do we need to follow? So step one is always, always, always look for a common factor. See if you've got a common factor in all the terms. Step two, if you have two terms, first see if you have the difference of two terms. Next, see if you have the sum of two cubes. And lastly, see if you have the difference of two cubes. So if you got two terms, see if you've got the difference of two terms, difference of two squares actually, and the sum of two cubes or the difference of two cubes. So just let me repeat. If you got two terms, you're looking to see if you have the difference of two squares, the sum of two cubes, or the difference of two cubes. Now if you have three terms, you have a quadratic most likely, and you follow the rules for factoring a trinomial using either the quadratic formula or any of the other rules we talked about in a previous lesson. Next, if you happen to have four terms, see if you can do factor by grouping. Finally, you want to make sure that you factor completely. You may find that you factor once and you can factor again. So make sure you factor completely. So these are the basic rules you need to follow if you are using if you are attempting to factor up any polynomial. Okay? So now, proceed to the worksheet, and if you have any questions, again, make sure that you post them on the discussion group, and I will try to answer them as quickly as possible. Do the problems without looking at the answers first, and then proceed to the mastery quiz.